Dear students, welcome to next chemistry lecture of periodic table. Now today we are here going to discuss about the next physical properties, ionic radii. So simply what is ionic radii, what are trends shown in periodic table, then what is cation, anion, how they are formed. All these parts are seen in today's lecture. So first we see just two concept. It is overlook on this concept. First one, effective nuclear charge and screening effect, how they affect these properties, or what are the different trends shown by these properties, particularly ionic radii. So in previous lecture we seen what is the effective nuclear charge, what is screening effect, and how they affect these properties. As we move across a period, the total shielding effects remains the same and the effective nuclear charge, that is Z effect, goes on increasing across a period. आपण जर पाहिलं तर त्या ठिकाणी शिल्डिंग इफेक्ट जो आहे, शिल्डिंग इफेक्ट सेम राहतो आणि त्याच्यामध्ये इफेक्टिव्ह न्यूक्लिअर चार्ज इन्क्रीज होत जातो. What about down to a group? As down to a group, Z effect decreases down a group as the shielding effect of the increased number of core electrons outweighs or cancels the effect of increase or decreases the effect of increased nuclear charge. Therefore, the effective nuclear charge goes on decreasing down a group. आपण डाउन अ ग्रुप जर गेलो तर त्या ठिकाणी इफेक्टिव्ह न्यूक्लिअर चार्ज डिक्रीज होत जातो. आता हे दोन कन्सेप्ट आहेत ते त्या ठिकाणी फिजिकल ट्रेंड्स असतील, त्या ठिकाणी periodic trends in physical properties, how they apply for next property, ionic radius. So simply first we see what is cation, what is anion, how they are formed. Simply cation, it is positively charged ions and it is obtained by removal of simply electrons. And what are anions? Anions are the negatively charged ions which is formed by gaining one or more electrons. So anion is formed with gain of one or more electrons and cations are formed or removal of one or more electrons. So measurement of distance between neighboring cations and anions in ionic crystals have been useful for estimation of ionic radii. So simply, what is the definition for ionic radii? It is the distance between neighboring cations or anions in given ionic crystal. Ionic crystal मध्ये त्या ठिकाणी कॅटायन फॉर्म झालेले असतील, anion फॉर्म झालेले असतील, त्याच्यामध्ये जे डिस्टन्स असेल ते डिस्टन्स म्हणजे त्या ठिकाणी आयोनिक रेडियाई असणार आहे. सो व्हॉट आर द ट्रेंड्स अक्रॉस अ पिरियड and down to a group? It is the same as previous physical property, atomic radius. So we see in details. As the across a period, ionic radii goes on decreases and down to a group it goes on increases. How it is? Simply reason for it. Greater the effective nuclear charge, stronger is the attraction of the nucleus for the outer electrons and smaller is the ionic radius. Across a period जर पाहिलं आपण तर त्या ठिकाणी नवीन शेल त्याच्यामध्ये ऍड होत नाही, तर इलेक्ट्रॉन्स ऍड होत जातात. शेल तीच राहते. शेल तीच राहिल्यामुळे शिल्डिंग इफेक्ट त्या ठिकाणी कमी होत जातो किंवा त्या ठिकाणी सेम राहतो. शिल्डिंग इफेक्ट सेम राहिल्यामुळे शिल्डिंग इफेक्ट सेम राहतो, परंतु इफेक्टिव्ह न्यूक्लिअर चार्ज इन्क्रीज होत जातो. आणि इफेक्टिव्ह न्यूक्लिअर चार्ज इन्क्रीज झाल्यामुळे त्या ठिकाणी इलेक्ट्रॉन आणि न्यूक्लियसमधलं जे फोर्स ऑफ अट्रॅक्शन आहे ते इन्क्रीज होत जातं आणि इन्क्रीज झाल्यामुळे डिस्टन्स कमी होत जातं. त्याच्यामध्ये कॅटायन असेल, anion असेल, जे काय असेल त्या ठिकाणी त्याच्यामधले जे इलेक्ट्रॉन्स आहेत आणि न्यूक्लियस त्याच्यामधलं डिस्टन्स कमी होत जातं. म्हणजेच त्या ठिकाणी जे रेडियस असेल, आयोनिक रेडियस, इट गोज ऑन डिक्रीजेस अक्रॉस ए पिरियड. is the reason as we may As we move across a period, screening effect caused by the core electrons remains the same. On the other hand, the effective nuclear charge goes on increasing. The valence electrons therefore more tightly bound, and in turn the atomic radius goes on decreasing along a period. Now, what about down to a group? What are the trends? As we move down to a group, the effective nuclear charge decreases and shielding effect goes on increasing. आणि प्रत्येक वेळेला नवीन शेल त्याच्यामध्ये ॲड केली जाते. फॉर एक्झाम्पल फर्स्ट ग्रुप ॲज बी सीन लिथियम, सोडियम, पोटॅशियम, रुबिडियम 2s, 3s, 4s, 5s एटसेट्रा. प्रत्येक वेळेला नवीन शेल ॲड केले म्हणजे कोर इलेक्ट्रॉनचा शिल्डिंग इफेक्ट आहे तो इन्क्रीज होत जातो आणि त्याच्यामुळं काय होतं इफेक्टिव्ह न्यूक्लिअर चार्ज कमी होत जातो. इट गोज ऑन डिक्रीजिंग. सो फोर्स ऑफ अट्रॅक्शन बिटवीन nucleus and electrons also goes on decreasing, or distance between both are increases. Therefore also the radius, that is ionic radius, increases down a group. So these are the trends of ionic radius across a period and down to a group. So students, we move towards the next point. Simply what is cation, anion, and just size of cations and anions. So starting with cation. A cation is smaller than the atom from which it is formed. How cation is formed? Simply on the removal of one or more electrons. Cations, positively charged ions. So why cation is smaller than the atom? Because it contains fewer electrons than atom. As we remove electrons from atom, original atom, so number of electrons in next species, that is cation, becomes less. So the nuclear charge is the same. As a result, shielding effect is less because electrons are removed from that particular atom to form a cation. As a result, therefore, shielding effect is less and effective nuclear charge is larger within a cation, so the distance between nucleus and electrons in cation is become less, so size become less, that is ionic size, or say ionic radius becomes small, so cation is smaller than the atom. This is the reason for a cation is smaller than the atom. It is asked for marks 2 question, very short answer questions. Now students, we move towards the next one, anion. An anion has a larger radius than the corresponding atom. How it is? As it has more number of electrons than the anion is formed by gaining of one or more electrons. So number of electrons increased in anion species than the original atom. So this additional electrons result in increasing electron repulsion, that is electron repulsion. The shielding effect increases because due to the increasing number of electrons in core electrons. So due to this, they decrease the effective nuclear charge, and in turn the increased size, the distance between the electrons and the nucleus in anions increased, and so distance increased, ultimately size increased. So anion has a larger radius than the corresponding atom. So these are the two concepts from this point. Now students, we move to the last point from this one. So what are isoelectron species, and what about their radii, or what traits shown by their radii? So as we seen in chapter 4, isoelectronic species, simply some atoms or ions contain the same number of electrons, and these species, that is atom and ions having same number of electrons, or say same number of electronic configuration, are termed as isoelectronic species. But actual nuclear charge of isoelectronic species is different, not same. The number of electrons are same, but actual nuclear charge is different. So the radii of isoelectronic species vary according to actual nuclear charge. How they obtain or how they get the nuclear charge, and depending on that, their radii shows various trends. So larger nuclear charge exerts greater the attraction for the electron, the radius of the atoms becomes smaller. If the nuclear charge is higher, then this isoelectron spacing becomes smaller, the size becomes smaller. Simply we see example of F minus and Na plus. F minus is anion which is formed by gaining of electron, and Na plus it is cation which is formed by loss of one electron. Both have 10 electrons. How it is? It is F minus. F having atomic number 9 and it gain 1 electron. So total number of electrons becomes 10. And what about Na plus? Not Na plus. It is obtained by loss of electrons. Sodium atom or sodium having atomic number 11. It lost 1 electron and there is a formation of Na plus. So electronic configuration for Na plus, not Na plus is also, or number of electrons also 10 electrons. That is F minus and Na plus both having 10 electrons. So they are called as isoelectronic species. So what about radii? The radii or ionic radii for F minus is 133 pm. That is picometer. It is the measure of the small distance or unit for the measurement of small distance. And what about ionic radii of Na plus? It is 98 pm picometer respectively. So how the nuclear charge appears the ionic radii of both these? As the nuclear charge for F minus is plus 9 than the Na plus, which is plus 11. So nuclear charge is greater, the size becomes smaller. So Na plus having size 98 pm as compared with F minus 133 pm. So this is isoelectronic species and their trends. So in next unit, students will say different trends or periodic trends in different properties. Remaining will be ionization enthalpy, electron gain enthalpy, and electronegativity. Dear students, as in this lecture we see just a concept of effective nuclear charge and shielding effect, then how they affect the different properties like atomic radius, ionic radius, ionization enthalpy, electron gain enthalpy, and electronegativity. Then we see in trends of ionic radius, that is how cations are formed with positively charged ions, how anions are formed, negatively charged ions. Then what are the trends? That is ionic radius goes on decreases across a period, and down to group they goes on increases. Now what about cation is smaller than the atom? Reason for it: a cation is smaller than the atom. It is asked for also very short answer questions, also for objective, so 1 mark. Then anion has a larger radius than the corresponding atom. Also reason for it. Give reasons. Question asked on this one is give reasons why an anion has a larger radius than the corresponding atom. Now last part, what are isoelectronic species? That is atoms and ions having the same number of electrons or electronic configuration. And what are the trends? Along with example F minus and Na plus with their electronic configuration having number of total electrons equals to 10, with their ionic radii 133 pm and 98 PM. So, dear students, thank you for joining this lecture.